Ratios of fractions is exactly what it sounds like. A ratio is a comparison of two numbers, and now those two numbers, or at least one of those two numbers, will be a fraction, and maybe both of them will be fractions. And so we have a key term, a complex ratio. And the definition of complex ratio is what we just said. A ratio where the numerator and or the denominator are fractions. So let's give you an example. If 3/4 of an inch of rain fell in 20 minutes, then let's write it as a complex ratio and then find the unit rate. So this is how many inches per minute, and that per means divided by. So 3/4 in or per 20 minutes. Now 20 minutes isn't a fraction, but can we make it a fraction? If we know that 20 minutes over 60 minutes would be how many hours, because really that's how rain is reported, right? How many inches fall per hour. So 20/60ths, I don't know if I want to write it over here, that'll help me reduce it. If I divide by 10 on top and bottom, that's 2/6, and if I divide that by 2 on top and bottom, it's 1/3. So 3/4 to 1/3, and again that's 3/4 of an inch to 1/3 of an hour. Well, really, I mean, the easiest way to do this is to see that per as division, because it really is. So maybe even rewrite it that way. 3/4 divided by 1/3. And the way that we deal with dividing fractions is to multiply by the reciprocal. So we leave the first fraction alone, change divide to times, and then reciprocate or flip the second fraction. And multiplying fractions is our favorite thing to do because we don't need a common denominator. We don't need to change anything. We simply multiply the numerators. 3 times 3 is 9. And we multiply the denominators. 4 times 1 is 4. And remember that this is inches per hour. And so we can turn that quickly into 2 1/4 inches per hour. And that's our unit rate, 2 1/4 inches per hour. So that's raining pretty heavily. So if Jenny ran 2,640 feet in 5 minutes, well, we can turn that into a complex ratio. Well, I picked 2,640 feet because that's half of 5,280. So you need to know that 5,280 feet equals 1 mile. So 2,640 is half of that. So we're going to find out how many feet per minute she runs. So 1/2, well, that's miles. Actually, we're going to find out how many miles per hour. So 1/2 of a mile in 5 minutes, and 5/60, if we just kind of do it over here to the side, that would reduce to 1/12. So half a mile in 1/12 of an hour. And again, you can scale up. You could multiply the top and bottom by 12, or you could simply turn 1/2 over 1/12 into 1/2 divided by 1/12, and then multiply by the reciprocal. So leave 1/2 alone, change divide to times, flip the second one upside down, or use the reciprocal. So that's 12 halves, and that equals 6 miles per hour. Is how fast she runs. So these would be our unit rates taken from a complex ratio. So this one's a fun one. The square shown is composed of smaller equally sized squares. The shaded section has an area of 1/4 square inches. Use unit rate to determine the area of the larger square. So we know that this section right here equals 1/4 of a square inch. So unit rate means let's just find out how much this is. So really, if we take 1/4 and divide it by 3, well, then that's the same as 1/4 divided by 3/1, which equals 1/4 times 1/3. So that one little square is equal to 1/12. Now I know this is confusing because you see that it's 1 out of 16, but this is 1/12 of a square inch, whereas we don't know how big that square is. So that 1 square is 1/12 square inches. I'll try to put the units right below it. Now we multiply that by 16 and we'll have the area of the entire square. So 1/12 times 16 over 1. Well, that equals 16/12. 4 goes into both of those, so when we simplify it, it is 4/3, or 1 1/3 square inches.